So now let us start with comparison of electromotive forces by using one more method, and name is given as a sum and difference method. In previous lecture, we considered this comparison by using individual or separate method, and we know that the formula obtained in this method is E1 upon E2 is equal to L1 upon L2. No doubt in this equation, L1 be the balancing length when first cell of EMF E1 was connected across the potentiometer, while L2 is the balancing length when second cell separately or individually connected across given potentiometer. Now this comparison is also possible by using one more method called as a sum and difference method. So what is basic difference between these two methods? In previous method we connected two cells independently or separately. Now instead of connecting these two cells separately, we can connect them, yes, combinedly by means of two combinations. The first combination is called as a sum combination or sum method, or that is the, yes, series combination. You just imagine two given cells when connected one after the another such that negative of first cell is connected to positive of second, means simply unlike terminal together. When unlike terminals are together, then these two cells are said to be in series combination. And when they are in series combination, total EMF is said to be their addition. As there is an addition in this combination called as a series combination, this first method is called as a sum method. Is it clear to you? Now in second method called as a difference method, we are going to connect these two cells, yes, with like terminal together. Means negative of first is connected to negative of second and then positive. It means that when like terminals are connected together, this combination is called as a, yes, difference method. D-I-F-F-E-R-E-N-C-E, difference method. Or it is also called as a parallel combination of cells. First method, sum method, is called as, yes, series combination of cells. Now difference method is also called as a parallel combination of cells, in which EMFs are E1 and E2. And suppose now E1 is greater than E2, then we can write resultant EMF of this combination is E1 minus E2. Now let us consider in detail construction and working of potentiometer, yes, in order to compare EMF of two given cells. So just consider this diagram over here, or circuit diagram, in which AB is a thin uniform copper wire which is connected with a main battery. Suppose this is main battery capital B. One key and rheostat RH are connected in series with this wire. Key is used just to start or stop electric current. Rheostat is used to control the current drawn from this main battery. So this is the potentiometer circuit, which is shown with black color in here. Okay. So this black color circuit diagram is nothing but potentiometer circuit. Construction of potentiometer already we discussed. It's very simple. A thin uniform copper wire AB. For the sake of simplicity, we have considered 4 meter length over here. To send electric current through this wire, a main battery having sufficiently high EMF, one key and rheostat are connected in series. Now, two given cell whose EMF is to compare, they are connected across this potentiometer. How to connect them? Similar way, see here, blue color circuit shown. Now, first cell of EMF E1, its positive terminal is connected to that point to which positive terminal of main battery is connected. This is always important precaution to be taken, so that balance point should be obtained over entire length of potentiometer. Now here, positive is connected to point A, negative terminal is connected to, yes, terminal 1 of a two-way key. See here, terminal 1, terminal 2, terminal 3, and this is terminal 4. This is called as a two-way key, by means of which we can connect two given cells respectively in series and parallel combination. That is sum and difference method. Now see here, negative terminal is connected to, yes, terminal 1 of this two-way key. Now terminal 3 is connected to, yes, a highly sensitive galvanometer. One terminal is connected to, means for this galvanometer, one terminal is connected to this key 3, and second terminal is connected to a sliding key, or also called as jockey. Now terminal 2, it is connected to negative of second cell, and terminal 4 is connected to positive terminal of second cell. You just consider here this second cell of EMF E2, whose positive is connected to terminal 4, negative is connected to terminal 2. Now suppose initially this key K is closed of this potentiometer circuit. Then certain current I will be drawn from main battery, which will flow through each and every length of this potentiometer wire, and it will work on the principle that yes, potential difference between any 2 points of this uniform wire is directly proportional to length of wire between these 2 points, which already we considered in previous video. Now here, this second circuit called as an external circuit, in which 2 cells are there. First cell of EMF E1, which is shown over here. Second cell of EMF E2. Now it is these 2 cells we are going to connect by means of this two-way key. Now suppose terminal 1 of two-way key, it is connected to terminal 4 and terminal 2 is connected to terminal 3. Now when such kind of arrangement is made, what happen? Negative of first cell get connected to positive of second. Negative via 2 to 3 it is connected to highly sensitive galvanometer. Now indirectly these 2 cells will be in series combination. Are you getting my point? Already I have mentioned, when unlike terminals are together, means negative of first is connected to positive of second, this combination is called as a series combination. Now here negative terminal of second is connected to this jockey via highly sensitive galvanometer. Now we have to repeat the same procedure. What is that procedure? Just touch the jockey to any one point on this potentiometer wire. As soon as jockey is touched to any one point on this potentiometer wire, what happen? This external blue color circuit is also completed, means certain current, say I dash, will be drawn from this combination. So this I plus I dash, both current will flow through this potentiometer wire up to this point. Again at this point there will be dividation. I dash, whatever current was drawn from this combination, it will be returned to negative of second cell and then again positive. In this way this external circuit will be completed. And now for further part, after removing this I dash, remaining current I ampere, it is continue to flow through this potentiometer circuit and this first circuit is also completed. Now suppose just go on sliding the jockey over entire length, and somewhere while sliding the jockey a point P is obtained. Suppose somewhere a point P is obtained. Suppose this is the position of point P, for which galvanometer shows zero deflection. If galvanometer shows zero deflection, what it implies? No current flows through galvanometer. No current flows through galvanometer. What it implies? I dash is 0. If I dash is 0, you tell me how much current is returned to this combination? 0 current. Means how much current is drawn from this combination? 0. So what it implies? Till all connections are made. See here, entire blue color circuit is completed now. All connections are made, but till no current is drawn from this combination. What it implies? This combination becomes an open circuit. As it becomes open circuit, we can say that total EMF, now as it is a sum method or yes, series combination of cells. Series combination of cells. What we can say? Total EMF will be equal to, what will be value of total EMF? It will be E1 plus E2. And this total EMF will be balanced by voltage between these 2 points of this main battery. Means we can write this is equal to VAP. But already we discussed, according to Ohm's law, we can write yes, VAP is equal to, means indirectly E1 plus E2 will be equal to VAP, which we can write as IRAP, because voltage is current into resistance. Resistance simply we have to consider between these 2 points. But we know that if sigma be the resistance per unit length, then RAP can be written as current, yes, resistance can be written as sigma into length between these 2 points. Suppose length between these 2 points, which 2 points? A and P, if it is assumed to be L1, then resistance RAP can be written as sigma into L1. Suppose now this is equation number first. So for this first method called as a sum method or series combination of these 2 cells across potentiometer called as a sum method, we got the equation E1 plus E2 is equal to VAP is equal to IRAP is equal to I sigma L1. No doubt here, already discussed in previous article, I sigma can also be written as a K, and therefore in this sum method, first method, we will get final equation as, yes, tell me what will be final equation? This final equation comes out as, in sum method, yes, E1 plus E2 will be equal to VAP is equal to IRAP, and that is equal to I sigma L1. This is equation number first, where L1 be the balancing length between point A and P, for which this galvanometer shows zero deflection or null deflection. Now repeat the same procedure. Repeat the same procedure with parallel combination or difference method of combination of the cells. Difference method means these two cells we are going to connect now in parallel combination. Now for that this two-way key is given. Now what to do? Just open these two connections now. Connect terminal 1 to 2 and 3 to 4. See here. When 1 is connected to 2, then via 2 terminal, via this wire, it is connected to negative. Means negative terminal of first cell then connected to negative of second. And now positive via this highly sensitive galvanometer connected to sliding key or also called as jockey. And hence now by means of this two-way key or also called as a commutator arrangement, yes, these two cells now we can reverse and in a parallel combination or also called as a difference method. Is it clear to you? Now repeat the same procedure. Just go on sliding the jockey or total length and obtain somewhere a point Q for which, yes, current flowing through galvanometer is 0. Current flowing through galvanometer is 0 means deflection must be 0. It means that I dash will be 0. I dash 0 means no current is returned to this combination, means no current is returned from this combination. It means that this combination or external circuit, this blue color circuit is said to be open circuit, and hence we can say that total EMF, as cells are in parallel combination, total EMF is E1 minus E2. It is balanced between point A and Q. Now suppose here length between point A and Q is equal to L2, then we can write VAQ is equal to IRAQ. But we know that RAQ is equal to, yes, we can replace as sigma L2. This is now equation number 2. Now bus experimental part is over. This is very simple. In first sum or also called as a series combination, we got E1 plus E2 is equal to I sigma L1. In second, this difference E1 minus E2 we got here I sigma L2. Now once these two equations are obtained, now this experimental part is over. This circuit is clear to you. Very important part here, commutator arrangement. First of all, one was connected to 4, 2 was connected to 3. So that two cells were in series combination. Now we have to reverse this terminal. Now to connect terminal 1 of this two-way key to terminal 2 and terminal 3 to terminal 4, so that cells will be in difference or parallel combination. So by means of these two equations now we will get final conclusion. What will be final conclusion? We have to compare EMF of these two cells. So how to compare? Simply take ratio. If we divide now equation number 1 by 2, yes, what will be ratio? E1 plus E2 whole divided by E1 minus E2 will be equals to, yes, L1 upon L2. Because during that ratio, I sigma L1 divided by I sigma L2, so I sigma get cancelled. Hence, I have written here directly, this is equal to L1 upon L2. Now we are interested to get comparison, means E1 upon E2. So what to do? There is one mathematical operation called as a dividendo and componendo. By means of dividendo and componendo, in Marathi it is called as a yog viyog kriya. So we will get here E1 plus E2, new numerator will be first numerator minus old denominator. So E1 plus E2 minus, yes, what will be the conclusion? Sorry, plus E1 minus E2. And new denominator will be original numerator E1 plus E2 minus original denominator, means minus E1 plus E2. This is equal to same operation you have to perform on this side. New numerator is equal to old numerator plus denominator, means L1 plus L2 whole divided by L1 minus L2. Now here we will get twice of E1 divided by twice of E2 will be equal to L1 plus L2 upon L1 minus L2. Now here 2 to get cancelled, and hence final equation will be E1 upon E2 is equal to L1 plus L2 whole divided by L1 minus L2. Very, very important equation. This is now final equation to compare EMF of two given cells. E1 upon E2 is equal to L1 plus L2 upon L1 minus L2. Important point to be noted. L1 be the balancing length when cells are in series combination, or that is the sum method, and L2 be the balancing length when cells are in parallel combination, or that is the difference method. Now another advantageous point after comparison. if EMF of one of the cell is known, we can calculate EMF of second cell also. So is it clear to you? So in previous video we consider comparison by means of individual or separate method, and now here we consider comparison by means of sum and difference method. Now till one more application is left for this potentiometer, and that is to determine internal resistance of a given cell, which we will consider in next video. Thank you.